Your academic learning becomes much more easier. If you are here to subscribe to our channel, do so. We have already some videos on alkane and introduction to hydrocarbon. If you haven't watched those videos, do well to make a review, watch them. And if you have any comment, any question, you can ask. Today I'm taking you down to another part of hydrocarbon, which is nomenclature of the alkane family. Alkane is one of the first family of the hydrocarbons. I've told us from the previous video that they have a straight chain and no branching. We can have cycloforms of alkane, so on and so forth. But today, basically, we're talking about the IUPAC nomenclature of alkanes. The IUPAC nomenclature. The IUPAC nomenclature of the alkanes. So, from carbon atom of 1, we call them the methane. We have seen that in our previous video, methane down to carbon atom of 10, which is called the decane. So if you have an alkane of this kind of structure, you know that this is the propane family. When we have hydrogen bonded, all through, and hydrogen bonded without any other different substituents. We call this the propane because we have 3 carbons. When there is 3 carbon, we call it propane. And there are principles to naming or rules guiding naming of hydrocarbons or alkane using the IUPAC nomenclature. One of the rules is that look for the longest continuous chain and check for any branching. After you have looked for the longest continuous chain, which is carbon to carbon, carbon to carbon, you still have to do what? Look for if there is any branching. If there is any branching, give numbering to that branching that will give it the lowest number. Like if there is a branching here, X, make sure you start your numbering from the carbon atom 1 to 3. So give this branching the lowest number. So you must give preference to this. So let's take a more real example. Just here is some structure A. Carbon bonded to 3 hydrogen bonded to carbon, 2 hydrogen, then bonded to hydrogen bonded to CH3, and bonded to carbon with 3 other hydrogen. This structure can also be written in this form. This form is the condensed form of this structure. So you can have your structure in this form and you'll be asked to name it. So if we face this kind of problem, the first thing we have to take to note is that our longest continuous chain. Where is the longest continuous chain? 1, 2, 3, 4. But if we are counting this way, we have a substituent at this carbon. So we can't count this way because this substituent is going to have higher number. So we have to give the smallest numbering to the substituent. So we'll go this way. This is carbon 1, 2, 3, and 4. So we've known the position of this constituent. But what is the name of this constituent? CH3 is called methyl. Where is the position of this methyl? 2. So we write 2. So the name is 2-methyl. How many longest continuous chain? How many carbons do we have on the longest continuous chain? We have 1, 2, 3, 4. 4 carbons. So the name for 4 carbon is what? Butane. So the name for this compound is 2-methyl butane. So this is the IUPAC name for this structure. And if you have it in this form also, what do? You look at where there is a branching or a kind of substituent in each of these carbon atoms. CH3, CH2, you know that there is no other branching here, but you have CH because the ideal number for number of hydrogen in a carbon straight chain should be what? Cn H2n plus 2 for the alkane family. So you can see now that we have what? We have 1 hydrogen here. So we look for where there is that particular substituent. This is the substituent attached to it. So we consider the longest continuous chain. This is carbon 1. This one is a substituent. So we don't take note of it as a carbon on the longest continuous chain. So it's 1, 2, 3, 4. So the substituent is at carbon number 2. So the name will be what? The substance itself is named methyl. So the name will be what? 2-methyl-butane. So from this you can also name without drawing a structure in this form. And the structure B we have here, we look into this structure, trying to know our longest continuous chain. 1, 2, 3, 4, 5. That is wrong. There is another chain going this way. So this is 1, 2, 3, 4, 5, 6. So we can see that we have 6 straight chain carbon and a branching at some of the carbon position. If we start our numbering from here, 1, 2, 3, 4, 5, 6. We can see that we have branching at carbon number 3 and another branching at carbon number 4. The branching here is methyl and the branching here is methyl. Even if we take a numbering from here, we call this 1, 2, 3, 4, 5, 6. The name is going to be the same because we have the same substituent. The substituent here is methyl and the substituent here is methyl. Branching here will be 3 and the branching here will also be 3. So the name for this is going to be, the name for this is methyl and the name for this is also methyl. So this is going to be what? 3, what's the carbon position this methyl is attached? 4, right? So this is 3, 4 dimethyl. How many carbon straight chain? 6. And 6 is called hexane. So this is dimethyl hexane. Using the same approach, we still have the same name for it. So this is how to name hydrocarbons or alkane family that has branching. We can also look at some other structures that has the halo compounds attached to it, or the nitro compounds like nitrogen and oxygen with all other substituents.